can intervene with Giordano. Giordano, can you hear me?
Yeah, I can hear you.
So I don't know if you heard my last words.
No, sorry. I just heard. Take your time and.
Okay, so I don't know if my microphone was muted, but in any case, on behalf of the 3D Smartbox partnership, welcome to this second workshop that will be presented by Giordano Vignoli from the Italian partner Lumen. I see that there are still people in the waiting list, so I would kindly ask the German coordinator to allow them. I think, I don't know if it is
I'm
possible.
allowing them.
I let them in, yes.
Okay, perfect. So, without losing more time, thank you very much to Giordano, and let's start.
Okay. So good afternoon. My name is Giordano Vignoli. I'm a teacher. I'm a science teacher, and I'm the expert from Lumen that will show you how to um, use the information that we provided in the toolkit to produce workshop and to teach in your classroom using the 3D printing process. We will see the main structure in this lesson, in this workshop, and in the next one. So we will stay together for 2 workshops. And this will be the starting workshop in which I will explain you uh, differences between printers. I will show you how to get a model. All the materials would be at disposal for you as in the presentation and in the toolkit, because I extracted material from the toolkit, obviously. So you don't need to write anything because you will find everything in the toolkit and in the presentation. I'll show you online repositories in which you could find the material, so the object to print. I will, because in the next workshop, I'll show you how to produce your own material with the CAD. We will see what CAD means. And it's a software, spoiler, it's a software. We could, so we will introduce the instrument next time. Now we will introduce the beginner part for 3D printing. I think that I'll wait just a second because I see that many people are connecting, and we could wait just a few minutes for 2 reasons. The first one is that my introduction will be useful for everyone, and the second is that blink, 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 blink in my hair when I speak. It's not easy to speak and to explain. So I will wait a few minutes to see if all the participants will be in. Just a couple of minutes. Okay. It seems that the reign of participants finished, so I could start to share my screen. Okay. First of all, we need, I hope that you could see my screen. If Otherwise, you could tell me. When we speak about 3D printing, when we imagine 3D printing in a school, because there are a lot of 3D printing technologies, we imagine two kind of technologies. The first one is the most common that many people have already seen in school or at their workplace, and that it's the main technology we decided to adopt for 3D printing. So the school that will have their piloting with us will use this kind of mainly this kind of technology. And the name is fused deposition modeling, or this is an additional technology in which the material will be extruded from an hot point. It's made of melted plastic, so mainly the material that will build the object is melted plastic, and it's easy and common in school because it's cheaper than other technologies of 3D printing, and it's less toxic than other ones, because we could choose the plastic polymer that we decide that we would use. Usually, the will be choose the PLA, that means polylactic acid. That it's a plastic polymer that became from vegetables, so it's not toxic when melted, and you can compost it. The other plastic polymer that usually is melted in fused deposition modeling. It's ABS, the plastic in which you could find the Lego bricks. Let's see what I mean for fused deposition modeling in this GIF. I'm click. Sorry. Okay. This GIF it's useful to understand which kind of technology we are talking of, because you could see that there's a plastic filament that is melted in an iron hot point of spot, and layer after layer the project will be produced. It's a prototyping technology. First of all, I would like to tell you that 3D printing is not a fast technology to use during activities. So, as we wrote in the toolkit, it's better to model or choose the models during lessons and print it out from lessons, because an object, a small object like this one that has been printed in this GIF, that is few centimeters, could take a few hours. So it's not a fast methodology. In particular, fused deposition modeling. The printers that we choose to support the school are a new generation fused deposition modeling printers. So they became always more fast, so so faster than the old ones. But anyway, it's not like to produce a mold. Usually, plastic is melted in a mold that produces multiplied copies. That it's an industrial production. Yeah, this kind of technology, it's slower than to produce a mold. Obviously, it's cheaper, and you could use it for prototyping because you don't need to produce a mold for multiple copies, but you could produce a single copy and check if the object reaches your target, or if you could change it. And so in prototyping for education, it's perfect. A second technology, stereolithography, or polymerization, uses a liquid resin. It's a plastic, but we will call it a resin that, with light, in particular UV ray, will tighten and will become hardened and produce your object. I show you what I mean, because it's more easy when you saw the project. So in resin 3D printing, you put a liquid resin, a liquid plastic, and you put inside the file. We will see which kind of file. And under the tank of the resin tank, there will be a light you see in the GIF, in the video. When the light turns on, makes a layer. Also, this is a layer methodology, but have a lot. You will produce a more definitive object. The quality is higher, because when we talk about fused deposition, FDM, fused deposition modeling, we speak about layers of 0.1 millimeters or 0.07. We speak about layers of 0.05 millimeters. So we could use really 0.5, sorry, millimeters. So it's the quality is higher, the precision is higher. You will have an object that in which you will notice the layers with more difficulty, like not like in fused deposition modeling, because the fused deposition modeling has high layers. But you, as you see in the video, you have to use gloves and masks, because the resin, when you touch the resin, and in particular the moment in which you pass the UV, it's partially toxic, and you have to be more careful. Obviously, it depends from the school, it depends from the grade of the school, but it's lesser easy to find it in school, because you have to be more safe than fused deposition modeling. The fused deposition modeling, the main problem could be that if a child touches the hot point, iron point, and burns, this is a toxic material. So it could be used, but wearing the safety instruments and safety protection. So one is less detailed but easier to use. The other one is very detailed but needs safety. The main thing that every person that starts to use 3D printing and 3D printers that want to know is when I could find a model or how I get a 3D model. Mainly, you could use three methodologies: scanning with a 3D scanner that captures the real object. You have to move the scanner all around and doing like photos, melted photos, at least 12 photos. Obviously, you have to buy the 3D scan. You could buy a cheaper 3D scan. There are also some applications that you could download for mobile phones, but are low quality scanner. You could use a hand scan, so you move with your hands around the object, or you could use a professional scan in which you put the object you would like to scan in the middle, and the high quality cameras will scan for you. So it's not easy to find in a school. The second possibility is to model using a CAD. CAD is a software that helps you to design. CAD means computer aided design. So it's a software that helps you to draw in 2 or 3 dimension. Obviously, for 3D printing, we need it in 3 dimension, and we will see a free didactical CAD the next workshop. Or you could use file libraries that are online collection of ready-made models. Obviously, you need internet, a device with a browser, and sometimes when the libraries are not free, you have to buy files. These are the three methodologies you could have a 3D object, a 3D object that you could use and print in a 3D printers. I decided to put some repository that you could find online, and you will find it in the presentation and obviously in the toolkit. And I decided to choose some of them to show you this evening, so you will know how where to find already built objects. The first one is the most famous. It's all free repository, Thingiverse. I show you this. Thingiverse, it's a community. It's not a single from a single person or industry. It's a community and made of thousands of makers that are people that produce the object, that scan it, that design it. And in Thingiverse, you could find many objects, hundred of thousand of them, that you could use for didactical activities. You could find, as you could see, we are just watching the home page. Okay, we could find designed object from cartoons, from books, from movies. We could find funny things. We could find cosplaying object, modeling object, or useful object that you could download as a free, because I remember you that Thingiverse it's open, and you could modify, you could add the 3D print the models to your models. You could do everything you desire with the model because it's Creative Commons, and you could download it as a free. As you could see, as if I'm a science teacher, so if I search something about cell, I could find many objects, 3D printed models for a cell, games. Made it, this is a plant cell construction. I printed it for my students, and 3D models about the subject and the object that they are researching. As you could see, when I click on the object, I advise you to log in and create an account to save the object, to create your collection and so on. They explain you what you will produce. They give you the file, and you could find also people in the community that made it and give advices, and that show their results. I think that someone here did a didactical kit. As you could see, they printed many objects to, I think, to for a game or to give to their students. The objects are made of different plastic colors. The the most common 3D printers have just one color at a time, but there are 3D printers that makes multicolor objects, but are more expensive, more sustainable because you waste a lot more plastic, and they are less easy to use. So Thingiverse is my first choice. Going on, you could find another repository called 3D, in which you could find free or payment STL. STL is the extension of the file, the most common extension of the file, in which you would download the file. Point STL, that means point stereolithography. As you could see, there are a lot of multicolor objects because 3D printing it's becoming also interesting for multicolor objects, but there are a lot of normal one color object, and you could find object to print. Could be useful, like this, could be just funny. You could I think that someone here made a robot in which they put their camera. So you could find a lot of useful and interesting things. Calls, as I told, it's part. It's could you could download a free file. You would find free files exploring it, or you could pay them because there are 3D artists that sell their operas and their work on calls. So for this, it's different from Thingiverse. The third one, it's GrabCAD, in which you could find free or payment tool objects. And also this is made for designer, but this is most commonly used from people that download technical structures. Obviously, you could find um, also educational category. Also, these are made from users of the community. Many of them are free, but some of them to download some of them you have to pay, and tells you which kind of file STL in this kind you will download, because there are other kind of object of extension that not are lesser common for 3D printing. So also these are the educational part, but usually it's for mechanical parts. So if you want to print a drone or a little car for your activity, it's perfect. If you want to find scientific or other kind of objects, lesser interesting. This creates a matosha, creates mathematical shapes from mathematical formulas. This is nice. I think that could be useful, more useful for secondary schools. And when you decide, you have to put the title of your object. You put the formula, which kind of graphic model you will design, and at the end you will generate. Obviously, I did not the object, but I didn't produce the object, but it's interesting for mathematical structures, and it's free, so it's interesting because mathematical objects are not easy to let our students to understand, because the solid and the mathematical structure are more abstract. My mini factory, it's like called 3D, is another repository in which you could find free or to pay objects, but it's more specialized in modeling animals and fantasy structure, but it's interesting also to check. So if you are searching models, they also produce a lot of interesting animal models, so dinosaurs, or you want to produce jigsaw animals to let your students mount them and so on, you could find them here. Then the more specialized site, okay, it's American. So as you see, like in other American governmental founded sites, there are lack of funds, in particular scientific ones. So you could find this disclaimer. You so it's more specific for scientific modeling. If I search Searle, you find 3D objects that are interesting to teach science, but you could find also other things, not only for science, but this is more specific. And you could also print objects for your laboratory, chemical structure, instrument to do the experiments, and there are a lot of things interesting, in particular for a science teacher of the higher grades, because they publish a lot of 3D objects, like cells and like organs, like chemical structure. So it's more specialized but interesting. Like you could see, this is a protein. So could be interesting not just for 3D printing, but also for 3D models to make a lesson. ThinkShape, it's a community. It's like Thingiverse. It's a community in which you could find free or to pay files, and it's more general. Also, here we could find um, many kind of objects, from useful objects like this resistor holder or phone holder and so on, or other kind of object for your lesson. As I said, we saw the argument on cell. I put cell. Let them seconds. I don't know which kind of object we could find, but they don't have something about cell. But you could see that there are free objects or other things you could pay. Printable is from Prusa. Prusa is one of the main brand for 3D printing. This is also a 3D community in which people put their objects. You could find also 3D models, free 3D models to print, or you could pay them. But they usually are free. Oh, interesting this. As you could see, they give you the model to produce sea pods, quindi interesting for science with a little bottle, and you could plant the seed. But you could find a lot of things. It's like Thingiverse or the a pin shape. So pin shape. You could find many interesting things. This is one of my favorite ones. It's the Smithsonian, the USA Museum site that has started a few years ago to scan their objects, their collection, and they give you the possibility to see in 3D their object, the object that they have in their collection, and many of them you could also download and print them. So I download the human skulls, Homo sapiens and Homo neanderthalensis skulls, to confront them, and my student could touch the differences. The 3D printing prototyping structure is fundamental because when you touch something, when you have in your hands, you could observe the differences. You could observe how a mechanism it's made, how um, the science, the history the real science history is made. You could see this is the burial. You could see the 3D model scanned, and under the 3D model, you could download for example, you could download object OBJ that is a particular 3D printing extension, but sometimes you could find also STL. This is the Mamutus. These are real their objects that they have in their collection, and you could download them and print some of them. I think that this is one of the most interesting things because you could explore a lot of collection. Are you interested in universe and also solar system? You could see a supernova explosion in 3D, and to see the model in some you could download. You could download skeletal parts, animals, or you could download artistic structures and objects, or part of scientific collection. These are objects from Apollo 11. You could see the object, the 3D rendered model, and you could download. So this is more, it's a lot of, has a lot of interesting, as you told you, hominin fossils that I downloaded. And your student could touch an object that is in a museum in the other part of the world. STL Finder, it's not a repository, but it's a finder in the other repositories. If I search cell, it gives me all the objects that are in other sites. So you could find new repositories, or you could have a more wider vision of objects, and that tells you where to find it. Then this is also from NASA, and like Smithsonian gives you the 3D rendering that in part you could just see, and in part you could download and print from objects. For example, the structure, sorry, it's a structure that has been it's been made from a photo, and it's a photo of clouds and gases of a nebula. I don't know where to find in other objects that are so fascinating. You want to print or just to see the site, the 3D rendering in which the Apollo 11 landed, you could do, because it's at disposal. And you could print asteroids and object and structure from the history of spatial trips. So everything it's free in the site, because it's from NASA, and it's a repository of 3D printing model and texture directly made from NASA. Thanks. It's new. It's like Thingiverse or the other ones, in which you could find, it's more similar to 3D cults. You could find free objects, or you could buy them. Turbo Squid Education, it's mainly to pay to download, but you could find also 3D educational models. Some of them are for free. These are really accurate models. It's more for we could see models for didactical activities. There are some of them that are cheaper, and others are expensive. But you could also download a collection of educative games. You could use also, some of them are to print, and other ones are 3D models that you could put in your presentation to let your students work with 3D models. The last one, you imagine, is like Thingiverse. It's a community, but it's more its main target is to sell files. So are more specific. You could find also free files, but it's made from the same brand that did Thingiverse. So this is more to pay, but you could find interesting files. Okay. After this list of repositories, we have to understand how to prepare a file for printing. We need another software. You have to make a slicing passage before printing an object. What means slicing? Slicing, it means that when you download or produce an STL file, it's a 3D object that is made in one shape. It's a solid 3D object. If you want to print it, you have to slice it in many layers. Otherwise, your 3D printers could not understand how to build it. So, a slicer, it's a software that slices in layers your solid object that you produced, and you need it to produce a 3D printed object. You could not pass directly the STL or OBJ extension file in the 3D printers. There are obviously, and we will see what a slicer is because I will show you one of the most common and free slicers. But if you buy a 3D printer, many brands have their own slicer. Other one uses a free one with their parameters. To slice an object, you have to follow some advices because it's not just to put the object in the slicer, then put in the 3D printers, and the 3D printers makes the object. You have to check. Sorry, just a second. Okay, you have to choose parameters for the slicer. I show what I mean. This is a slicer. This is Cura. It's one of the most famous free slicer, and it's from Ultimaker, the brand that did the Thingiverse, that did you imagine. This is the brand of the 3D printers we bought for the Italian schools, and this is the model of the 3D printer that I used last time. I have to open the object. Okay. This is my object. Okay, I'll show you another one because it's horrible this. Download. Let me see. Okay, this is the case for microcontroller sensors that my students built during an activity last year. As you could see, you have a solid object. It's made of one shape. It gives you the measures and if you decided that the right 3D printers, this is the plate of the 3D printer, the dimension of the plate in which you could put the object. So it's not a problem to move. If you move in the slicer, you will move, you would print in the position in which you put the object. And you have parameters to decide. I'll show just the recommended and not the custom ones that are explained in the toolkit, but we will not talk about them today. Okay, you have to choose the quality of the object. When you do more thin layers, the quality of the object obviously will be higher. But when you produce thinner layers, the time of printing will be longer. So you have to decide the dimension of the layers. If you just want something faster to see the object, if you want to use it and to see lesser thin layers. So this influences the quality of the object and the time of printing. Infill means that you could decide to print an object full 100% or almost empty. Inside the structure, you will infill you will create the printers will create an algorithm that produces structures that could print the object with lesser plastic. We will see after the slicing has been made. Support. What means support? When you produce, when you print an object like this, there are some part of the object that doesn't touch the build plate. This is empty inside. So when you print it, it depends on the hole on the object. When you print it, the plastic will be attracted to the build plate and melt and not solidify in the right way. So if you make a substructure, it's a structure that you will cut off after the slicing. I think that I could show you to let you understand better because it's 3D printing substructure. Okay, this structure. Remember this. When you do the object, this structure helps you to put the resin or the plastic in the zone that otherwise will print worse. When you do a substructure, the substructure will be cut off and you will have the object at the end. You cut off the substructure and then the object will have higher quality. It depends on the object. Some are made to be built without substructure. Some are too much complicated and you need the substructure like glasses, as you see. These glasses have a substructure that you cut off and gives you the glasses mount. This depends on the grades of the overhang. If the degrees are lesser than 45, like in this imaging, you don't need a support structure. Otherwise, you need it, or your object will not print in a good quality. Adhesion, it means that when the 3D printer starts to build your object, starts earlier and starts to put plastic on the build plates to increase the part of your object that will adhere to the build plate. So if you have an object like this that has a lot of its shape that adhere to the build plate, you don't need it. If you have a more complex object, you need it. Then I could scale it, I could rotate it, I could do many changes in my structure, in my shape, and then I will slice it. The slicing tells you the time, if you put the right model of your 3D printer, the time of printing. This is a simple object. It's not so big, but you see, 1 hour and 10 minutes, and how much grams of plastic you will use. When you slice your object, you could preview it. As you could see, now the object is sliced. I place the support structure, and inside the object there's the support structure that I will cut off, and this is the adhesion to the plate, because they started earlier to put more plastic to adhere to the plate. This is the layer production. This is the hot part of hot hands that melt the plastics, and this is it will be 166 layers, and you could see all the layers as a preview. If you see that there's an hole, that something is wrong, you could intercept before printing it. As you could see, we could see the structure, this squared structure. This is the infill. If I put more infill percentage, I have to do again the slicing because it changes. As you see, the squares are smaller, so you will use more plastic. If I use lesser infill, this is 0, so it's empty. You could see that the box will be empty. What to do? I mean, which one is the perfect one? You have to check it. You have to produce a lot of. I'm changing the profile, so the layers thickness. You have to check, to try many things. You have to produce different prototypes. It depends on the result you're interested in. The experience will help you to choose. As an advice, if you are prototyping something just to check if the object it works, do thicker layers and lesser infill. If you're producing something to expose it, to paint it, because you could paint it with acrylic paints, okay, then do thinner layer and maybe a longer, higher percentage infill, because with lesser percentage infill, it would broke easily. And then in the preview, if you click for this software, you see the movement of the hot hands and all the passages, that it's more easy to check and to let our student to see than than the production, the real production, because the printers is low. There is not enough room to put our student near the printers. And so you could show them what the printers will do for the layers. It's a good compromise to didactical compromise. Okay. When we, sorry, I closed. I'm opening again the software. Okay. And I have to put again. Okay. This is a puzzle that we did with primary school students. These are political regions, Italian regions. They produce it with the CAD from an image and did the puzzle. All the student, this has been built with a CAD from the students, so it's also possible for primary school. Searching the object we will use it. Okay. Another thing important when you, oh, sorry. This is his big, they made a mistake with scale. So it was a really enormous object. When you print an FDM project, you usually I advise you to put not so many objects in the same file, but just one, because when you 3D print with the FDM the objects, the 3D printers will do this. It starts from one object, then passes to the other objects. As you see, it moves from one object to the to other objects. So it's so much slower. Obviously, if you have many small pieces, you could print together, but it's more, it's faster to produce one by one the objects. It's different from the resin printer because the resin 3D printer has a screen and prints all the objects all together. So it's faster, and because it every layers it activates light under the object, so it's easier and it's lesser complex to print many different objects. This is an advice when we when you will do the first 3D printing object, a 3D printed object. Stop, just a second. Okay, so a slicer slices in many layers. We will see again the procedure. I put the object, I open the object in my 3D printer. This gray one is the build plate, so I decide in which part to build it. I recommend you to build, if you have just one object, more centered possible, because the 3D printer will be more precise, and the layers will be easier to build. Then I decide the dimension. I decided when I built it, but if you downloaded an object from a repository, you have to decide the measures. If you want to scale it, you could decide uniforming scaling. I want to print it 50% of the dimension. I want to print it 100%, or I just want to uniform scaling, but I decided that the dimension of the X axis will be 200 millimeters. Then it scales the object to the, okay. Then when you decided dimension, you have to decide the profile, that is the thickness of the layers. Infill, that is the percentage of plastic or of the room in which you will put the plastic. This influences the dimension, the precision of the objects, but also influence the timing of the production. Infill will be the percentage of plastic put inside. From 0, it's empty, to 100%, it's full, completely, it's full. And if you choose lesser percentage of infill, it will be faster to print, but you could break it easily. Let me show you. If I slice, this is the maximum thickness of the layer, so it's faster. This is the lesser percentage, 0. It's empty. 2 hours and 51 minutes with 191 grams of plastic. If I do the opposite, infill 100% and 0.1 millimeters of thickness, 1 die, and 13 hours. As you could see, you will need a lot of plastic more, 1 kilo, 1 kilo and 300 grams, and 37 hours. Okay, so you have to choose the right thickness of the layer and the infill percentage you need. You could do a lot of tries and prototypes. Just to let you know what means custom, in this custom that I advise you to don't use in your first 3D printing session, you could decide the quality of putting the millimeters, the quality of the thickness. You could decide the dimension of the shell, so just not just the infill, but the dimension of the walls of the structure, the shell, the first layer, the last layer, the percentage, which kind of structure, grids, lines, triangles, hexagon. And this, it's interesting to check when you produce something to see the resilience of the structure. Material, the printing temperature, PLA prints from 180 degrees to 220 degrees. And if you are, but an ABS from 220, 210 degrees to 230. So you have to decide which temperature of the hot hand, and if it's built, if it's present in your printing, and in more modern printers, it's all usually present. If the build plate could become more warm. If you print ABS, you have to use the build plate temperature. If you use the PLA, you could use also the hot end temperature. So it depends on plastic polymers or from your 3D printing. If you don't have the thermic resistance in your build plate, you could not choose this one. But in my model, it's present, so I actually could choose it. Print speed, how much millimeters from second. New printers start from 200 millimeters from second per second. The old ones 40, 50 millimeters. So it depends on the model of the printer, and you could decide if you could, when you build more objects, you enable retraction and as we saw, passing from one from other. And if the cooling fans that are useful to because it's a melted material, so if you use the cooling fans, you could harden faster, and which kind of support. Okay. Then, just to recap, because I don't want to give you too many informations to absorb during one lesson. And we will talk about 3D modeling and CAD in the next one. We saw which kind of technologies of 3D printed we could have in a school. Fused deposition modeling, that is made in plastic, and it's more common, easier, and cheaper, but the results are lesser quality ones. Stereolithography with resin, that it's uses light to harden a liquid resin. You could produce a very detailed object, but the resin is a little bit toxic, so you have to use gloves and masks if you use in your school. How to get a 3D model, scanning it, modeling it, or taking from file libraries. Which we saw a lot of repositories, free ones and to pay ones, in which we from which we could download the files. How to prepare a model, which what's a slicer, which kind of model we will produce. Sorry, I didn't see that the slicer modify the convert the file from point .stl or point .obj, that are most common 3D files, in a slide software that has the extension G code. So if you find a G code, it has already been sliced. Okay. So we, in this second workshop, saw what we need to 3D print and where we could find the object, and in the next one we would see how to produce by ourselves an object 3D print, and how to use for didactical activities. Any question? I give you a lot of information. I know that. Okay. Thank you. Any question? Doubts, curiosity, information? Obviously, I will be at disposal also during the next workshop, at the beginning of the workshop, if someone will have something to ask from this lesson. But I think that we have few minutes to answer to your questions. Okay. So Alessandro. Ah, okay, Silvia. Yeah. So on hand.
Is Sylvia able to participate or? Maybe she has got some issues, but in any case, we will meet in the next workshop, so it will be possible to write us and to have new questions about this. Or in any case, you can contact your regional partner in order to have clarification so that we can support you even during the days in which there are no workshops. So, if someone wants to stay connected to have some more questions, you can stay connected. We will be at your disposition. Otherwise, I would like to thank you all for participating to the second meeting and remind you the next meeting that you will find also in our project website, but it will be the 9th of October. So it will be in 2 days, always at 5 o'clock. And you can use the same link you will find you already used today because it is a multi-link, multi-event link. So you can use the same link for connecting to the next workshop.